Hello friends, in this video, let us understand how to avoid the recomputation issue. In the previous video, we have discussed about dynamic programming approaches and the recomputation issues in the top-down approach. We can avoid the recomputation issue using memoization. To avoid the recomputation issue, we need to store the result of sub-problems in the separate memory, so that when we face the same sub-problem again, we need not solve them again. Instead, we can reuse the already solved result. This is called memoization. Let us understand it by solving the same nth Fibonacci problem using a top-down approach with an array additional memory. To find the fourth Fibonacci number, allocate 5 memory slots. As we know, the base case fib of 0 is 0 and fib of 1 is 1. So store 0 and 1 in the memory. The idea here is, before making any recursive call, check if it is already solved in the memory. If it is solved, just return the result, otherwise initiate the recursive call to solve the subproblem. So fib of 0 and fib of 1 are stored here. Now fib of 2 will be calculated, which is fib of 0 plus fib of 1. Now fib of 0 and fib of 1 are base cases and are already stored in the array. So fib of 2 will be calculated, which is 0 plus 1 equal to 1. And it will be stored in the array. Now fib of 3 will be calculated. It is not stored in the array, so compute it. That is fib of 2 plus fib of 1, that is 1 plus 1 equal to 2. So fib of 3 equal to 2 and it will be stored in the array. Now fib of 2 should be calculated, and when it is checked in the array, it is already computed and stored in the array. So it is only a matter of returning it from there. We do not need to call fib of 0 and 1 recursively. So the repeated work is not occurring here. Now fib of 4 should be calculated, and it is not already stored in the array, so compute it. That is fib of 3 plus fib of 2. That is 2 plus 1 equal to 3 and it will be stored. This is how memoization avoids the recomputation of same sub-problem in the top-down approach.